Now for comparing the spread. So this is the third feature that we need to do. So we're going to look at the width of the boxes and say, are they about the same size? So you can see here I'm just drawing some red lines to represent how wide the box is. And remember that box is my interquartile range, which is the middle 50% of my data. Okay, so it's looking around about that centre, how much spread there is around the centre. And what I notice is that the male's box is wider than the female box, and that's what we want to be able to say. So this is for achieved. I'm just going to say I notice that the spread of the middle 50% of my female bags is slightly smaller than the spread of the male bag weights. Okay, or I could have done it the other way around and said the male bag weights are slightly bigger, slightly more spread out than the female bag weights. Okay, that would be fine too. For my merit, I need to justify it. So now I need to actually calculate the interquartile range. So hopefully you remember your formula for interquartile range, which is the upper quartile take away the lower quartile. So here's my interquartile range for the females, and that's got an upper quartile of 5,000, take away the lower quartile of 2,000. So that leaves me with an interquartile range of about 3,000 grams for the females. Do the same for the males, and I get a slightly bigger number, which is what I expected, that the males were a little bit more spread out. So now for the writing the sentence, I've got to think, well, which group has got the biggest interquartile range? And in this case, it's definitely the males. So now I'm going to add my because for my merit. So I'm going to say that it's the reason I can say this is that the interquartile range for females is about 3,000, whereas the male's interquartile range is 3,400 grams. So that's my evidence of how I know that how I can prove that the spread is bigger.